So welcome back again. We were talking about NS assembler directives. NS assembler directive is going to be useful to inform assembler uh, that this is the end of segment. It means this NS is being used to indicate the end of the segment. As I mentioned earlier, there can be data segment, there can be stack segment, there can be code segment. So segment is the assembler directive which is being used to indicate the start of the segment, and NS is being used to indicate the end of the segment, right? Similarly, we have got ENDP, NP. NP is going to be used to indicate the end of procedure. Okay, and end is used to indicate the end of program. So in one program, you can have this end means the complete end of physical end of, I mean, the end of the entire program, right? So end is being used to indicate the end of the entire program. NP is being used to indicate the end of procedure, and NS, which is being used to indicate the end of the segment. Now, next assembler directive is assume. What is assume? This tells the assembler the name of logical segment which is to be used for the specified segment. For example, assume CS colon code. This is the format. Assume CS colon code semicolon DS colon data. What does this means? This means your code segment name is code and data segment name is data. But here you need not use code, right? CS, this is code. This is very important. CS is code segment and DS stands for data segment. This is name of your code segment. Similarly, this is name of your data segment. This name can be anything like assume CS Aurangabad. It means your code segment name is going to be Aurangabad. DS Jalna means your data segment name can be Jalna. So these are logical names. Logical names can be anything, right? Need not be code and need not be data, but for the sake of simplicity and for the sake of better documentation, it is advisable to use the similar kind of convention so that it will be easier for anybody to understand, right? The next assembler directive is EQU. EQU is used to assign some value. It is used to assign some value. Like for example, TEMP EQU 04H. What does it mean? It means that this 04H is going to be initialized. This temperature is going to be TMP is the variable which is going to be initialized by 04H, or 04H is going to assign to temperature TM variable. Right? This is similar to DB. Like you can have like TMP DB04. The effect is going to be the same. The only thing is that whenever we are defining declaring this by using DB, it means you cannot store more than 1 byte data. Whenever you are defining this EQU, means it is open-ended. You can assign 1 byte data, 2 byte data, 3 byte data. It is open-ended, and that is why sometimes it is better to declare. Better to use EQU assembler directive in order to initialize some data to the variables. Next is ORG. ORG is the assembler directive which will tell assembler to assign address to data items or instruction in a program. It means, like for example, this is particularly being used to use in the beginning of the program, like ORG 0100H. ORG 0100H. What happens actually whenever you will be writing assembly language programming, and whenever you are assembling, and whenever you are doing execution of the program, at that time what happens in the memory mapping is going to be done by assembler. The memory mapping is going to be done by assembler. Whenever we are talking about memory mapping, so your the microprocessor kya karega? Microprocessor is going to assign some memory location to the program instructions. So what should be the start of memory location, right? What should be the starting address of memory location? So if you don't initialize, if you don't use ORG, then microprocessor will take it randomly. Okay, if you really want to ensure that your program is going to start from 0100H or 800H, whatever, if you are intended to start your program from a specified memory location, then it would be better to use ORG assembler directives. Next assembler directive is PTR. PTR is again a kind of operator. It points the type of memory access. Type of memory access means you can see here. Like You must have seen this kind of instruction. Like, forget about this byte PTR. First of all, you have we have studied this instruction MOV. Let us say MOV BX comma 58. MOV BX comma 58 without square bracket. Okay, MOV BX comma 58. So what will happen if for this kind of instruction, what is the action? What kind of action we are expecting? 58 is going to be initialized, going to assign to BX. Okay, if it is MOV BX comma 58, right? So obviously what will happen, because 58 being a 8-bit data, so it goes to BL and BH will be 00. So BX, content of BX would be 0058H. But if it is MOV square bracket BX comma B 58, meaning would be this 58 is going to be initialized to the memory location, whose content is in BX. Whose content is in BX. Now the question is whether only one data item is to be initialized or two data item is to be transferred. Okay, that is going to be a kind of confusion to the assembler, right? By providing PTR directives, it is going to be very clear. Like now in this example, MOV byte PTR square bracket BX com 58, it means that we are going to transfer only 1 byte of data. We are going to transfer only 1 byte of data. It means only 58 is going to be transferred to the respective memory location whose address is in BX. Has it been like it? We can have MOV word. You can have MOV word PTR BX. Then in here you need 16-byte data. In that case, 16-bit data. Sorry, 2-byte data. This is only 1-byte data, because here if you are using word, then you can use 16-bit data. It means this PTR, this operator is going to provide, is going to use to avoid, to minimize the confusion rather. Okay, because this will be, if you are using PTR operator or the assembler directive, it is going to be, because this is going to be preceded by a byte or word. Okay, so it need to be like before that, prior to PTR, either you have to use byte or you have to use word. If you are using byte, it means you are intended to transfer only 1 byte of data. If it is word, it means you are interested to transfer 2 byte of data. So then in that case, you can use 2 byte of data. So this PTR operator is going to be useful for minimizing the confusion in this kind of instruction. Next is length. Length is the assembler directives which is being used to calculate the number of element in the specified variable. Number of elements in the specified variable. Like for example, MOV CX length array 1. MOV CX length array 1. It means whatever this variable is there, what is the length? Length is 1, 2, 3, 4, 5. There are 5 characters, so this 5 number is going to be initialized to CX. So MOV CX length array 1 means the length of this array 1 is going to be initialized. The value, actual value is going to be initialized, going to be transferred to CX. CX is going to be initialized with the actual length of this array 1 data. Then next is size. It gives the assembler byte number of bytes allocated to a data items. It gives the number of bytes allocated to data items. It means like whatever number of bytes which are being allocated for the data item, that is going to be understood by that is going to be informed to the assembler. Similarly, offset, it determines the offset value. Like offset means what? Like let us say you must have seen the offset value. Let's say our physical memory locations start from 1000, right? 10,000, because as far as the physical memory location is concerned, it need to be a 20 byte, 20 bit long, right? Offset value is how far you are from the beginning. How far you are from the beginning. Like if your offset value is 1000, it means you are 1000 away from your first memory location. So this offset keyword assembler directive is going to provide that sort of information to assembler, that how far you are from the first memory location. As I mentioned earlier, there are two different kinds of assembler, MASM and TASM. So more information, little bit more information about MASM. The MASM is Microsoft Assembler, abbreviated as MASM. It's an assembler for Azure 6 family microprocessor. It was originally produced by Microsoft for development work and on their MS-DOS operating system, and was for some time the most popular assembler available for that operating system. So MASM used to uh, all these assembler. Let me tell you, TASM, MASM cannot be used with Windows because we have to use this with MS-DOS only. DOS is a kind of Microsoft DOS is kind of operating system, very old operating system, and that is why this MASM and TASM, like whenever you will be doing practical, you cannot use with Windows. You need to go to DOS operating system, and then you can operate this MASM and TASM. Similarly, the TASM is turbo assembler, as I mentioned earlier. There are more. I am going to code you some more example about all those assembler directives which we have discussed so far. Let us start with segment. As I mentioned earlier, segment is being used to indicate the beginning of the any segment, right? This is the example. You can see segname, SEGNAM, segname, followed by segment, and then it is going to be segname ls. Now, instead of, you can make it very simple. Instead of this, you can use sum, sum segment, and then sum ls. What does this means? This means that this segment name is SUM. This is the start of the segment. Here you can write some 8086 instruction. Once you, like, let us say this is code segment, right? This is, let us say, code segment. So name of the code segment, here you can write code, code segment, and then some instructions, and the end code ns. So this is how the segment directives can be used whenever you are writing assembly language programming. Similarly, I can tell you example of assume also. Right? Assume is again, as we have already discussed what assume is. Assume is one of the assembler directives which will again indicate the start of the logical segment. Again indicate the start of logical segment. Like you can see assume segment register colon segment, right? Or segment register column segment. Like for example, assume CS colon code semicolon ds colon data. It means the code segment name is going to be code, data segment name is going to be data. So whenever we are calling assume means you are ultimately directing assembler that the name of the code segment is going to be code, name of the data segment is going to be data. If it is like instead of code, you can write, as I mentioned earlier, assume CS colon Aurangabad, DS colon Jalna. It means Jalna would be considered as a logical name for data segment. Aurangabad is going to be considered as a logical name for code segment. You can see here, right? Assume CS colon A code, DS colon A data. So this A code is the name of the logical name of the code segment, and A data is the logical name of data segment. So you can write any name, A code, B code, C code, whatever, that is going to be name of your code segment. Then as I told you, origin 1000, like org is going to be used to inform assembler that this is what your starting memory location of your program should be, right? Similarly, EQU, as I mentioned earlier, EQU is used to allocate some data item to some variable. Like loop is the variable, and 10FE is going to initialize to loop. I mean, loop is going to be initialized with 10FE data item. And this is again example of even, right? Like what this even is going to do, you can see here. This is a small example of segment, like data segment. You can see is data segment org1200 edb4ch even and bdw, like that. What does this means? We have seen here A DB4CH means A is the kind of variable which is going to be defined as a byte type variable, and 4C data is going to be allocated to A. DW means B is a kind of word type variable, and 1052 is going to be initialized with B. Now question is, whenever we are talking about memory mapping, what should be memory location for A variable? What should be memory location for B variable, right? Now since origin you have initialized with 1200, this even will ensure that there would be like even memory location consider for each and every data variables. Like you can see 1200 will be starting memory location, and location for A would be 1202. Location sorry, because starting, because we have started from this itself. So location for A will be 1200 and location for B will be 1202, because we have used even variable. Then this is again the name of procedure. You can see here PROC. So this is the PROC is the kind of keyword, a kind of assembler directives. But you need to give some name, right? Like say, like proc name, PROC, near oblique far. There will be return statement. This return statement will be useful. The return is not assembler directive. Return is 8086 statement. NP is the end of logical end of this procedure, right? And this proc name is going to be name of procedure. Now this you can write, let's say sum or divide. Let us say name of this procedure is sum, SUM sum. So you can write sum, PROC, and this is near. Near means in the same program. Like near is intra segment. Far is inter segment jump. We have seen like short is again short, and near is intra segment, and far is inter segment, right? So you can use sum PROC near, sum PROC short, or sum PROC far. Return is going to be there along with some statement. At the end, sum NP. Why NP? Because this is the end of procedure. So this is a kind of logical name of procedure, and this NP indicate the end of the procedure, and this indicate the start of the procedure. This can be like, as I mentioned earlier, this can be near and far. Near means you can see add 64 PROC near, and then how you can add 64 NP, and this return is the end of the 8086 instruction. Because once you, because you know this is the difference between call and go to sorry, call and jump instruction. In case of jump, once the control is transferred to subroutine, it's not going to come back because it doesn't have that subroutine, doesn't have return instruction. And moreover, while executing jump instruction, the next address which is to be fetched is not going to be stored in the stack memory location. Whereas whenever we are executing call, the next address which is to be fetched is going to be stored in stack, and then control will be transferred to the desired loop, right? Or subroutine, right? Similarly, as far as the PROC is concerned, you can see you can have the two different kinds of procedure, either near or far, or third could be short. Near means intra-segment, far means inter-segment, right? So this is how it is to be defined. Add 64 PROC near, and then add 64 NP, and this return is the one of the last statement as far as the subroutine is concerned. And same thing is true with far as well. Similarly, as far as the short is concerned, short is again intra-segment. Displacement is going to be only 8 bit, whereas in case of near, displacement would be 16 bit. So plus or minus 127 here, and there plus or minus 32K as I mentioned earlier. So jump short ahead. Jump short ahead means what? This short is going to be like your address is going to be displacement address is going to be only 8 bit, and that is why since it is 8 bit, it is going to be plus or minus 7F. And this macro, and NM, this is not included in our curriculum, so I'm not going to mention that. Okay, so this is how we have. This is, I mean, these are some of the assembler directives which we have included in the curriculum. now we are going to have the question answer session. I know, because this is going to be very tough first time, like since we are doing online lecture, because had this lecture been a physical lecture or offline lecture, I would have asked a question while discussing each and every assembly directives. But since it is online, the option was not there. But now what we can do, we can start from first slide rather, and whatever doubts you are having for each and every assembly directive, you can raise those doubts now. Thank you very much.